And we have Steve Wilcox from Cambridge. If it's Cambridge, Massachusetts, then I'd love to join you for lunch, Steve, later. Okay, so let's get going. I'm going to share my screen. So welcome back, everyone, to the QuantUniversity lecture series. As you all know, QuantUniversity has been doing these lectures for the past couple of years online and in a live stream mode. And primarily, we focus on the topics which are near and dear to financial analysts, people who are in the financial industry, and who are now looking at various technologies, especially with the fintech boom and bust maybe, and also with the advent of data science, machine learning, and many of the frontier areas. We are now grappling with all the challenges with how to address all the various opportunities which are out there and integrate it with the various workflows we have within the industry, but also handle the various risks associated with that. So my role as an educator over the past 10 years, teaching at Northeastern University, Babson College, and also through QuantUniversity, I do a lot of work in the academic segment, trying to understand what are the various things which are coming out from a research to an industry mode, but also seeing some of the challenges, working with practitioners, working in the industry as a consultant and helping people with various aspects of incorporating these technologies within their workflows. How are things going to be affecting their day-to-day routines, but also seeing how you could responsibly adopt these technologies. So the last few months, you've heard about algorithmic auditing, the NIST Artificial Intelligence Risk Management Framework, and boom, ChatGPT comes in, and everybody's talking about ChatGPT and large language models in the last few weeks. And there isn't going to be, if you scroll through your LinkedIn or Twitter feed, every probably second or third tweet or LinkedIn post is going to be associated with something related to large language models or ChatGPT. Now, I have been tracking this for a couple of years now with natural language processing and large language models. In fact, we have some case studies already integrated with some of our courses at QuantUniversity. But the advent of ChatGPT basically brought something which was predominantly accessible for researchers and people who are working with natural language processes to everybody. And that means that now there are so many opportunities to starting from summarizing documents to putting together outlines to very intricate use cases wherein you could more or less craft entire documents, craft entire speeches, and you have the potential to build upon applications which you never thought about would be possible in your lifetimes. In addition to that, we are also hearing a lot about the risks associated with it. And in today's session, my goal is to give you a preview of some of the opportunities which are out there with ChatGPT and other large language models, and also talk a little bit about the risks. And this is kind of a preview to a new course which we're going to be offering in the context of generative AI. And I am going to kind of give you a 60,000-foot view today, but also delve into some of the depths of what does it mean when you talk about GPT-4 and think about integrating it from a financial services professional's perspective. And I'll give you a little bit of reading materials you can go and delve into and dig deeper into what's actually happening. Much better options than just scrolling through summaries of LinkedIn posts, if you will. But in addition to that, I also want you to be aware of the potential possibilities which are out there. And this is not going to be something wherein we are going to just hear about it and kind of let it go. We will see a lot of pragmatic applications come out, and you have to be open to, how do you integrate it within your current workflows? How do you test it? How do you evaluate it? So there are a lot of questions being asked. So I want to have this opportunity to discuss my thoughts in this presentation and also open it up for Q&A. That way I can hear your thoughts about what you think about this whole area and how we can potentially learn and grow together as these technologies evolve. So for people who are new to our lecture series, I started QuantUniversity 10 years ago. So May is when we'll hit our 10th year anniversary. So I've done my tour of duty at companies like Citigroup, MathWorks, and The last 10 years, I've been teaching at Northeastern University in the Master's in Information Systems program. And I also teach a fintech course in the business administration program there. And I've kind of tracked the whole evolution of machine learning when it started out with just building basic Kaggle notebooks to production systems, which are more or less powering various workflows within large enterprises. In addition to that, we also offer a lot of services through QuantUniversity. We have a whole practice wherein we do algorithmic auditing, model risk and evaluation, but also we do a lot of teaching. We work with companies, large asset management companies, large institutions, wherein there is a need to understand both the technologies, what is machine learning, what is data science, et cetera, which are like I would call the Explore, Experience, and Excel series, wherein we are trying to understand what these technologies are capable of, but also associated with the risks associated with the various technologies and how to potentially evaluate and address those potential risks. So today I am going to be we have another 50 minutes or so. So I want to start with a big picture orientation of what the large language model revolution is. And then there are so many models which are out there. Google has Bard, OpenAI has GPT 3.54, depending on whether you have access to it or not. But then you also have Lambda, and there are a lot of other companies which are coming out with various both open source and custom versions of large language models which are out there, which means that we have to first understand like what are these models capable of, what can we potentially use. And I'm not going to restrict this discussion to just ChatGPT, because ChatGPT is basically a web layer wherein you're invoking the API through a text box and you're just putting in information and getting back answers. I want to go under the hood and talk about how do we access these APIs, which means that you can integrate it with workflows. You can build it as a part of your practice so that you can basically send in specific commands and then get back the outputs, and also add filters and think about your governance and policy layers. That way you can make sure that the applications are robustly built when you have a lot of things which we still don't know about, which kind of comes to the risks associated with these models. And I'm going to try and share a high-level picture of what are the potential risks out there as we talk about what is out there, because right now the technology is so new and people are still talking about like, well, what are the potential risks? Because this is, especially with GPT-4 and GPT 3.5, we do not have access to the underlying models. We only have access to the model through an API, which means that a lot of researchers, a lot of practitioners are trying to understand the risks associated with that. And then I'm also going to show you a case study to get started, because some of you or most of you have probably worked with ChatGPT, which is the web-based front. But I also want to show you the power of potentially leveraging the API. And I'm going to use a case study on search. So I actually spent a couple of years building enterprise search engines, 2008, 2009 timeframe, worked for a company called Indica, wherein we were potentially thinking about question answers and looking at search as an enterprise problem. But now with GPT and also some of the newer technologies out there, search is becoming much more enriched in terms of the way in which you can access information, not just through keywords, but using semantic search, using ways in which you could provide context to what you're searching with. So I'm going to show you one case study and help you kind of connect the dots there. This is a part of one of the case studies we have in the new course, which is coming up. And if you are interested, you can pursue it further. The course is not available yet. It's going to be available from May, but I'll give you some more details. So let's kind of start delving into what the AI and large language model revolution is. So as a financial services professional, you've been tracking this for the past couple of years. We have seen centers of excellence emerge in various companies. You have seen a shift from people trying to do traditional statistical modeling and building out workflows associated with primarily driven by human intelligence, to delegating it to machines by either making things go faster, potentially leveraging some aspects of machine learning to enhance workflows. And we are seeing a lot of interest in building out data science practices within large organizations. So guess what? My students at Northeastern University, most of them for learning machine learning, they are going in and they're building out these kinds of applications in the real world, which means that there is a huge interest in these technologies, especially with the open source access to these technologies and also the availability of large data sets. Now, if you were a quant, I kind of introduced this because you want to connect it with traditional financial applications. Because as a quant, my training back in the day was predominantly focused on risk factors and distribution fittings and simulations and optimization, et cetera, et cetera. But now we are seeing a whole integration, and there is a paradigm shift towards potentially leveraging natural language processing, deep learning, machine learning, integrating it with chatbots. So the way in which we access information is becoming much more human-like, wherein we are trying to make it the interaction with these systems rather than it as input, the model does something, and we get back an output. We are trying to make it much more interactive. We want to do what ifs. We want to see things in the context of, well, if I change this parameter, what happens? And we want that ability to do a back and forth. And that's kind of where the paradigm shift is happening, wherein instead of we just thinking of mathematical finance problems and problems in finance as input, model, output, to a way in which we could have the dialogue with these systems. Now, if you think about your traditional machine learning flow, you will have noticed that there are so many elements. And I bring this picture back again, because guess what? With GPT, you are going to be building these kinds of pipelines within your organizations. It's not just going to be you crafting a very specific problem statement and throwing it to either Bard or GPT and then getting back a response. It's going to be building out workflows. In fact, in the last couple of weeks, I have 48 graduate students in my class, and we've split them into 12 teams, and we had them do a hackathon. So each one of them had to come up with a problem and then use some of these APIs and build out entire workflows and show a fully developed working application on how you could potentially leverage the API. Guess what? The API access is the simple part because you have documented ways in which you can access the API. But how are you going to be fine-tuning your data sets so that you can ask the right questions? Because this whole area of prompt engineering is becoming something which everybody needs to know about if you are going to be working with these kinds of APIs. The question is, how do you craft those prompts, and what goes into building out these prompts in the first place? Which means that some of these traditional workflows, which you probably already have for established machine learning, will kind of be required to make sure that you're collecting the user inputs, tying it to associated data sets, building different kinds of contexts, using different kinds of prompts so that you can interact with these APIs and build out your applications. So in that realm, what I'm going to do is when people talk about ChatGPT, they probably, it's becoming like the Xerox of the world, if you will. If you hear about, on Bloomberg Radio or any other news media, so everybody talks about, GPT. And the best way to ask people about, like, what do you know about GPT is to just basically expand the acronym and explain what GPT actually means. So with that, at least if you don't take away anything from this class, you hopefully by the end of these few slides, you will at least have an idea about what GPT actually means and how are we kind of evolving these concepts. And so let me start out with this notion of a foundation model. And many of the links I've provided to you are universally accessible. I'm not purposefully referenced really intricate documents. I'm kind of trying to keep it as high level as possible because it's an introductory webinar. And I've provided you a lot of links in Wikipedia, which has a very good, rich information with respect to what these actually mean. So the last few years, we have seen people talking about this notion of a foundation model. And the key idea here is, in traditional machine learning, if you're going to be, thinking about label data sets, you have features and then you have associated values, either numeric or categories. And then you build out your model so that you do a fitting of the features associated with a particular process to your outcomes and basically train the model so that whenever you have these specific features, you can potentially predict a particular outcome, right? So that's traditional machine learning, which you are probably all familiar with. Now here, what we're talking about is, so we have a lot of unlabeled data at scale, and typically what we call as self-supervised learning is used. And then you build out a model. And right now, this model doesn't have a very specific purpose. If you're thinking about like a machine learning model for credit risk, you have a very clear idea on where this model is going to be used. But a foundation model is not really fine-tuned towards a business process or an application. It's basically built out so that you can customize it and adapt it to a large variety of downstream tasks. So if you kind of search about foundation models in arXiv or other papers, you're going to see this notion of how do you build out this really large model, and then how can you customize it or adapt it to very specific use cases. Then we start talking about this notion of large language models. So people who have been exposed to natural language processing, back in the day, you had this combination of linguists talking about how grammar is used for structuring these various aspects in the language, and then you had the machine learning capabilities wherein you could potentially have large amounts of labeled data sets, and then you had to think about, well, how do I build out a question answering system? How do I build a summarization system? How do I build a classification system? If I'm going to be doing sentiment analysis, how do I structure it as a problem? If I'm going to be doing keyword extraction, what do I do? So those were like the individual problems which we were potentially looking at when we're talking about natural language processing methodologies. In fact, many of the natural language methodologies which were written in the 2010s probably are already dated, because right now the whole notion of a large language model basically is built on neural networks, and it's trained on large amounts of unlabeled data. And most likely, these large language models cannot be built from scratch within your organizations, because it requires really, really large amount of compute, really, really large amounts of data. So that's why you have companies like OpenAI and Google and Microsoft and Facebook or Meta. These are the companies who have the compute, who have the ability to go and scrape the internet and then kind of get really large amounts of data and train these models, are coming up with these innovations, and they are publishing it out. So this was something which kind of happened not a long time ago, in the 2018 kind of time frame, wherein people were talking about, like, what if you build this really large language model which could do multiple kinds of natural language processing tasks, which could potentially be used for various kinds of applications. So that's where it kind of started coming up. And then this whole area of generative AI or generative artificial intelligence is basically becoming more and more popular. And the goal here is, as some of you have already been exposed to, applications like DALL-E, wherein you could provide a text and it would generate an image for you. Your ability to potentially say, this is a Van Gogh image, and this is a picture of my house, and I want to adapt the style of a Van Gogh image to my house and see how it's going to generate. So this notion of generating different artifacts through a large model is becoming more and more popular. And the way in which you access these models, either through text or through images, and basically you're providing a prompt, and then you're basically generating these models. So again, in the context of natural language processing, so here, we are basically, if we're talking about like GPT-like model, so it is basically a generative model, which is a large language model. And what it's doing is basically, have been trained on billions and billions of parameters, and it's going to be predicting what the next potential word is going to be based on the prompt, and it's going to be generating text for you. And that's why, when you see your responses from ChatGPT and other areas, the crafting looks very much professional, like someone who really knows English has written, for example, right? So because you're looking at millions and millions of ways in which you can actually render sentences, and the machine has learned to be able to generate new text. And there is no thinking involved in here. It's basically a probabilistic mechanism to figure out what's the best possible output you could generate based on the data you're seeing, and also based on the context in which you're providing these results. So we've talked about foundation models, we've talked a little bit about large language models, and we've talked about generative AI. So let's kind of tie them together. So one thing to note is there are specialized architectures in neural networks. For people who are familiar with neural networks, there's a whole neural network zoo. If you're going to be building a convolutional neural network, there's a specific architecture. If you're going to be doing a recurrent neural network, you have a particular architecture. So there are various configurations of neural networks which are out there. So there is a specialized architecture called as the encoder-decoder network, which is going to be some of the basis on which we're going to talk about in a bit. But this is something you need to be able to understand. And the notion here is, if I'm going to be building out some kind of a translation engine, and if I'm going to be using some kind of an encoder-decoder mechanism, so if I say something like the input is like, I want to buy a car, end of sentence. So the encoder is basically going to encode this message into these. Basically, you have a set of encoder blocks and a set of decoder blocks. So depending on the task at hand, so you're going to be encoding this information. And basically, when you decode this information, and this is if you're going to be translating it into another language. So this is basically what the output potentially is going to be. So you're going to be training a network with, if this is the input and this is the expected output, what are the set of parameters for this network, which makes this particular thing happen? It's basically this notion of an encoder-decoder network. And many of the generative AI systems are using these kinds of architectures. Now, what happened was in the 2017 timeframe, there was a paper called "Attentional is All You Need," and this particular paper basically, built out what was called as the transformer network. And so here it basically uses this encoder-decoder mechanism, and then it adds what's called as an attention mechanism. And this particular paper basically revolutionized the way we think about large language models. And they did a whole analysis, and they did like an English to German translation. And they said like the results are going to be really good if you use this kind of an architecture called as the attention mechanism. So here, this notion of a transformer comes in. So we have kind of talked about what generative AI is, what transformers are, what encoder-decoder networks are. So we're kind of putting all those things together. And that's where GPT comes in. Basically, GPT stands for Generative Pre-trained Transformers. And the whole goal is, so it's a specialized architecture which leverages all these mechanisms. And it's basically a large language model. And it has been an evolution for many, many years now. And OpenAI, which is the company behind GPT, so they had GPT-3, and now recently they've released GPT-4, which is a multimodal architecture wherein it can take both text and images, and it can generate new text. So this is basically the technologies which is basically driving this whole GPT engine, if you will. Now, we don't have, because OpenAI hasn't made this model completely available. So they've just given technical specifications on what it has, and they've given a model card of what this particular model does. But we do not have, at this point, complete architecture which can be used for reproducing this particular architecture. So, but the fascinating thing about this particular model is it basically is a really large model. Has billions and billions of parameters, and as most of you have already tried out, it's surprisingly good when it comes down to things like text generation, translation, classification, et cetera, including generation of code and other kinds of artifacts. So the area is developing really, really fast, and we have, with the introduction of ChatGPT, the technology being available to a lot of people who potentially are not going to be familiar with encoder-decoders, who are not going to be familiar with transformers, who do not have any idea of how machine learning actually works. But because we have an API, you have the mechanism through which you can access these really complex models and get back responses. So that enables a lot of different possibilities. So if you, and I just took a sarcastic slide from, just kind of screenshots from various areas, if you will. So a lot of people are now trying it out, and coming up with answers and sharing them on social media, saying, hey, I tried this and this is what I'm seeing. People are coming up with speeches, people are coming up with outlines, and now there is power which is enabled through the access through this particular API, wherein you can do various things which were not possible before without you having to intricately understand the mechanisms which were behind it. And obviously, a lot of companies are catching up. Obviously, companies like Google, they had various technologies, Lambda and others, and they're now building out services like Pod, and they're integrating it with search. A lot of companies are building custom large language models. For example, Salesforce has what's called as Einstein GPT for primarily CRM-related activities. And then there's also a lot of concerns which are popping up. A lot of companies are basically enhancing their policies, but also countries are kind of putting blanket orders saying we cannot use this, or they are trying to see how it could potentially be regulated. In the financial sector, we have seen a lot of companies now updating their policies, basically saying, look, if you are going to be putting this information, we don't know what's going to happen with that information. So we are going to be preventing you from using customer data or company private data to put into these models. So that's something you should be aware about. And most companies have already started to issue guidances on what you can and cannot do within companies. In addition to that, you are seeing a lot of new applications which are coming out, and Morgan Stanley basically had an announcement that they'd been working with OpenAI for many years, and they're trying to reduce the amount of research time it would take to potentially research certain articles and other things like that, and helping financial advisors get richer information so that they can make decisions faster. Companies like Bloomberg, they have built out like a whole model called Bloomberg GPT, which is a $50 billion parameter model. I presume they're trying to make $50 billion out of it, probably. But it's basically built primarily for finance so that you can ask intelligent questions. I don't know how many people are Bloomberg certified in here. You probably know the pain in which you have to think about the various keys so that you can get specific information. When I was at in Citigroup, I had mostly fixed income related stuff. It got into my muscle memory. And if I had to write down or if I had to think about the command, it would never come. And I had to be in front of the keyboard, and it would be in my muscle memory to basically get those screens. But with probably access to these kinds of models, you're asking questions and potentially being able to get specific responses are going to be much easier. And then obviously NVIDIA, which is the company which makes the GPUs, which powers many of these large language models. So they are partnering with various companies and creating very specific large language models for various areas. Now, I want to spend a little bit of time talking about what GPT-4 is, and I'm going to give you a very quick overview so that we can get to the demo, but I also give you resources you can work through. And this was something I sat for like 6 hours on a plane and just reading this paper through. I took some notes, and some of it was concerning, some of it was things which I was thinking like, wow, this is amazing. But again, I'll share some of these thoughts in here. But I think you should definitely, if you are going to be using GPT, or if you are planning to use any large language model, you should definitely take a look at the technical paper, the GPT-4 paper. So this particular API, obviously, it's not completely accessible to everybody yet. So you have to request access to this API. And if you provide a use case, whether you're in a company setting or in a research setting and you want to get access to it, so they'll give it to you. And also, I think if you are a paid member of ChatGPT, I think they call it GPT Plus, so you will get access to GPT-4, but primarily through a web interface. So here, as you can see, we are using GPT. This is the generative pre-trained transformer, which I briefly introduced before. The one additional thing to note about is it's multimodal, which means that it can take different kinds of inputs to generate outputs. This amazing things which are possible with this particular model, a lot of things like text summarization, machine learning, etc. But here you're seeing some human-like intelligence, if you will, wherein it was able to solve questions, and it was in the top 10 percent of the test takers for a simulated bar exam, and for various benchmarks for English language. It was able to answer multiple choice questions, and it outperformed various models very easily. So you are seeing a lot of concerns in schools. In fact, I was speaking to a student from a local high school, and she was saying that because of ChatGPT, her school is now mandating all the work to be written by hand. They didn't want a copy and paste from ChatGPT, so they're asking all the essays and all the responses to questions to be written by hand. And she was saying, like, at least it'll make you read and understand and write what you're doing rather than just doing a blind copy and paste. So there's been a lot of concerns about things, but also you're probably also hearing about people attributing certain things to people, which is probably not true. But also you're seeing certain false facts come out as answers from ChatGPT, which with a very confident sounding note, which is now making you think, like, what can you trust if you're getting responses with the same authority and with the same confidence like you would normally get in a search result? Would you trust it? Because this whole answer was never there. It was not scraped from a website. It was actually generated by the algorithm on the fly based on the question you're asking. So the problem is, it's not fully reliable. And there's this notion of a context window. And when you think about using this API, you're going to be, providing X number of tokens and as a part of your query, and you're going to get back X number of tokens as responses. And you can basically customize how many tokens you want the responses to be within. And the reason why this notion of token is important is OpenAI charges you based on the number of tokens. So when you look at the pricing, they'll basically say, if you're going to be running a query, which is going to take X amount of resources, you're going to be spending X number of tokens, and we'll charge you for so many tokens. So that's the revenue model for them, but it's not very transparent and reproducible on our end. So as someone who's going to be using it for financial applications, wherein you have fiduciary duty and you're making sure that your risks are potentially addressed, it brings a lot of new challenges which you had never thought about before. In addition to that, there's a lot of discussion on, like, what does this model actually do? And they talk about, in generality, about what the model does, and they basically say, we don't want to reveal all the underlying details, but they talk about the process. They hired many experts, and they use this process called as reinforcement learning with human feedback, so that they could basically align what humans could potentially expect as answers, and also avoid controversial topics to make sure that the responses, if it was something controversial and was illegal or whatever it is, so you would potentially put in best practices saying, do not answer this kind of a question, respond back with a generic answer, or respond back with an answer saying, sorry, I cannot give you this information, even though the model actually comes up with an answer because it had been trained on all the information from the web. So they are talking about balancing and minimizing risks, but again, it's a very generic statement. There isn't like a very clear idea on what levels of risks are they addressing and how are they actually deploying this as a part of the practice. In addition to that, there is this notion of, well, when people ask questions and come back with responses and say, look, ChatGPT doesn't do this well. I asked this question and gave me a terrible answer. So there is this notion of prompt engineering, which is extremely important for you to understand so that you can actually leverage the most out of these models when you're querying it. And that's an engineering problem, I would say, because it's not that the model is not capable of answering certain things. You haven't expressed the question in the right way. And one of the ways in which you could potentially enhance it by providing better prompts so that you get more reliable results. And also, you can potentially fine-tune your application with specific data from your particular domain. And that potentially is required for very specific vertical use cases like finance, healthcare, et cetera. And then there could be options wherein you are not going to be getting results. So you have to draw a line saying, well, if I do not get these kinds of results, I'm not going to deploy this and move on from there. So this reliability guide, which I provided you a link, has a cookbook wherein they talk a lot about, like, how do you improve reliability? And I'll just kind of share a little bit from this particular paper or this particular link. So here, there are a lot of things which you have to think about as you're generating these queries. Now, how do we do queries? Now, when you follow a recipe for cooking, right? So you know what is the recipe. You know there is a sequence associated with it. Certain ingredients need to be put before, has to be processed in a particular way so that you can extract particular results. Similarly, you have to give very clear instructions to the API so that you get back the best responses. And you may have to explicitly say, if there is a complex task, then split it into modular, smaller tasks so that you can actually do these subtasks and then aggregate the results. In addition to that, you have to think about querying the model for answers. How did you come up with this answer in the first place? And if the rationale behind answering is not something which is very convincing, you may not want to use those results. So you may also want to ask for justifications. You may want to generate multiple outputs and then pick one among the best outputs. And you may also want to think about fine-tuning your model. So these are all suggestions which have been given in the OpenAI cookbook to enhance the quality of the results you're going to get when you access this. So this, again, I would say is an engineering problem rather than something wherein it's not specific to just generically ask questions. You have to engineer it so that you get the best possible responses. And here are some papers and here are some tasks and links wherein you can potentially think about how do we do things. For example, if there's a lesson saying break complex tasks into simpler subtasks and consider exposing the intermediate outputs to users. So this whole paper talks about how do you chain the various things which needs to be done as simpler subtasks. You can improve output by generating many candidates and then picking one of the best. So here there is a paper which talks about training verifiers to solve math word problems. So there are so many papers wherein they have potentially thought about a particular way in approaching results, and then they're given some rationale, and there are some papers which goes behind the details on how it was done and what tests were done. So you're looking at an aggregate because you have one API which can do so many things. And the question is, what are the best practices so that you can leverage all the things from this particular API optimally, right? So I'm going to skip through some of the details in here. I'll share the slides if anybody is interested, but these are like generic things which I wanted to just emphasize as part of the discussion, because when we talk about traditional machine learning, and this was like close to 10 years ago now, people are talking about, well, model is just one piece of the big puzzle. And the same thing goes with GPT. It's not going to be the center of all the things. It depends on how you're going to manage all these other complex things which needs to be engineered so that you get the best possible results. And secondly, the whole area of MLOps has matured significantly. And you all know there are so many processes in place when you're handling data. So access to these APIs are going to be the next step, if you will, on how do you customize these pipelines so that you can accomplish these tasks optimally. And that's the reason why you're seeing a lot of investments going into generative AI and building out new APIs, building out new products associated with that. And obviously, you have to think about all these risks. Where does the data come in? What data can you put into the model? Where are you going to be running all these queries? If you have private data and you cannot share it outside of your firewalls, how can you even access these APIs? Do you want to use an API which is closed source and you just have access to an API, or you're going to download an open source large language model and customize it for use case and host it internally? All these are things which you have to think about. So I hope this introductory discussion kind of gave you a little bit of insights on some of the things which you have to think about as you're building out your applications. What I'm going to do next is just give you a quick demo on one use case on how to use this particular API. And hopefully it'll kind of open some of the eyes for what you could potentially do with this. Now, I'm going to be using with the NIST data set. So here, the problem we want to address is if you have gone to the NIST website, the Artificial Intelligence Risk Management Framework website. So this is basically was released recently, and they talk about the various aspects of artificial intelligence risk and the various ways in which you can govern, you can measure, and do various things associated with it. So this is a knowledge base. And if you are a company which wants to adopt some of these practices, obviously this is a great resource and you will be able to go through it. But if I have very specific questions on specific areas associated with this particular document, it's extremely hard to search through the results. Obviously, there is a search engine, but the search engine is a traditional search engine, so it doesn't have like all the capabilities wherein you can potentially. So I'm going to get the demo in a second. Give me so here, the goal is to build out a question answering system using GPT so that you can basically ask any question in this particular website and get back responses. So it's more or less building like an intelligent chatbot, which can answer questions associated with a particular website. So how are we going to do that? We are going to be, there are multiple ways in which you can do that. There are two possible ways. One is you could potentially say, okay, you know what, I'm going to take all this data and fine tune my model and then have my model answer questions associated with this particular domain. In this particular case, because the large language model is scraped from data from the web, you may or may not get responses which are by default, if you just use GPT, you may or may not get the right kinds of responses because we are focusing on a very specific domain. One methodology which is becoming extremely popular is this notion of retrieval augmented generation. And it uses the same OpenAI API. But in order to do this, what we do is we basically say, okay, let's scrape the entire website and process them as text snippets. And then what I'm going to do is I'm going to compute embeddings on these text snippets and store these embeddings. Now, when someone asks a question associated with a particular topic, I'm going to compute the embedding for that particular question and then find out in my repository, are there other snippets which have very similar embeddings? And if I find text snippets which are very similar in terms of embeddings, I'm going to use those text snippets as context when I pass this request to OpenAI's GPT API. So if you search for retrieval augmented generation, there are papers, there are applications which you can build irrespective of the OpenAI GPT API. But I wanted to illustrate on how you can do some prompt engineering so that you can get better results when you're doing contextual search with respect to using this particular API. So let me illustrate that through a demo. That way you can kind of try it out on your own, if you will. So here, what I'm doing is, this is, I don't know how many people have seen it. So this is the sandbox we use. It's the Q sandbox. So basically, you have all these projects you can try out. It's an experimental test bed for various things. So when we do risk assessments, we use the sandbox to basically bring in the application and then kind of look at the various facets associated with risks and then build out the tests associated with it. So here, this is the OpenAI experiment. So you could basically structure the tests. You could do security reviews. You could do algorithmic assessments. We do these kinds of things for evaluation of models. And we also have a toolbox which is tied into it. So you have all the tools which are built out already. That way you can say, oh, I want to do some tests for fairness or bias or explainability, et cetera, et cetera. So in this particular case, let's just look at the code now, because for this particular demo, the code is the most interesting part. So let me, I've run this already. So I've used my OpenAI keys so that it can access it and send the query. So if you are not familiar with that, you have to go to the OpenAI website and then either get a trial or you have to provide your credit card information so that you can get an OpenAI API key. And once you have the OpenAI API key, you could potentially then call these APIs programmatically and get back responses. So here I'm just using a simple Google Colab notebook and writing out the code, and that way I can do the scraping and everything. So here, the first section is basically, and I'm leveraging some of the glue code or the startup code, which OpenAI's cookbook already provides. And then I'm just customizing it a little bit so that I can accomplish my particular use case. So many of these functions are already available in the OpenAI's cookbook. So you can just leverage it, which is already out there. So in this particular case, what I'm doing is I'm crawling the NIST RMF knowledge base site. So when I do my crawling, it basically comes back with all these pages. And if I look at like the sample data, if you will, or the text. So you can basically see that these are all the pages it has kind of, scraped. So once I do my scraping, so this is basically what I'll see, like, here's the associated text with it. And then I've more or less like just looked at all the links from that particular page. And then I've scraped the entire set of pages so that I can build a very contextual search engine from that. Okay, so now that I have taken all this text, I'm going to be using this package called tick token and then basically tokenize it. And we're going to use this tokenizer, which will basically take this and then tokenize it. So here, we are going to split it into a maximum of 500 tokens so that I can compute the embeddings on these text snippets so that I can do my comparison when I get new queries. So here, I'm just basically chunking it into snippets of 500 tokens each. Okay, so once I do that, I have my data, which are now in snippets of 500, of size 500. Now we are ready to call the OpenAI client library. So here, I'm going to install the OpenAI client library. I'm going to call the, I have an API key in a text file, so I'm going to get my API key. And here, I'm going to use my retrieval augmented generation. So here, I'm going to compute the embedding using this model text embedding ADA002. There are so many embedding models you could potentially use. I'm just using one of them. So what that means is for each one of my text snippet, I'm going to compute my embeddings. Now, once I have these embeddings, and then it basically tells you like how many tokens are there in this particular segment, and then you have the associated embeddings. Now that I have my embeddings, I can basically now start asking questions. So when I ask a question, I basically say, okay, create an embedding for the asked question, and then compute the distances from the embeddings to the asked question to the ones I already have in here. And then basically, compute the distances and sort them, and then use the first few to basically build out the context. So here, when I run that, so I'm creating my context. So here, for example, this is my prompt, and this is where my prompt engineering comes in. So I'm saying, answer the question based on the context below. And if the question cannot be answered based on the context, say, I don't know. So this is my request to the OpenAI API. And for the context, I'm basically taking the engineered context. So when I got my question, I computed the embedding, looked at text snippets with similar embeddings, packaged it, and provided that as a context. And then I can, I basically have a simple function wherein I could take any question and then ask that question. So these are some help functions. So let's kind of, try it out. So when I say answer the question, what is model validation? So here, what it did was it took this, computed the embeddings from the NIST RMF side, found out, are there other text snippets which has information about what is model validation? And it came back with this answer. Model validation is the process of assessing and documenting systems, operations, et cetera, et cetera. So here is a very specific question. What is the 4 functions of the AI RMF, right? So let me say, so let me go to the AI RMF website. So this is the AI RMF website. So I basically asked the question, what are the 4 functions of AI RMF? So this is what the current test results look like, right? So here you can see that when I ask a very specific question, what are the 4 functions of AI RMF? I'm not getting very clear answers. I have to go through it, search through it to find out what's actually happening. But here, the answer is there. It's in one of these websites. As you can see, this is the knowledge base which we scraped. And when we scraped it, you could see that there are there's the core, there's the profiles, there's a playbook. So there's a playbook for measure. There's a playbook associated with the manage, map, et cetera, et cetera. So there are all this information is somewhere in here, but I'm not able to find it. So here, when I run it, what I do is I basically have what are the outcomes of the 4 functions of AI-RMF. So it basically went in, looked at the context, and now it says the 4 functions for AI-RMF is govern, map, measure, and manage. The outcomes of these functions include categories and subcategories that are subdivided into specific actions and outcomes. So this, you can see the govern, map, measure, and manage. So it was able to scrape this website and govern, map, measure, and manage. So it was able to extract, these are the 4 functions of the AI-RMF. And if I say summarize the manage function of the AI-RMF, so here if I go in and say manage function of the AI-RMF, so you can potentially say this is the manage function. So you can say risks are prioritized and acted upon based on a projected impact, and you have all these aspects of manage. Now, if I wanted to just kind of read through the whole thing and understand, it's obviously going to take a lot of time. If I just wanted a brief summary of what this means, I'm asking this question, so it comes back saying the manage function of the AI-RMF entails allocating risk resources to mapped and measured risks on a regular basis and as defined by the govern function, and gives you a nice summary of what it actually means. And this is like, what is TEVV? It comes back saying it's test, evaluation, validation, verification. So, and if I say question in 100 years, will humans exist or will AI kill us all? This is obviously not answered in the AI-RMF. It comes back saying, I don't know. Okay, so hopefully this demo gave you an idea of how you can engineer applications using this API. Now, we don't know, all the tests which could potentially be done to validate these APIs. And that's actually a fully open question, because you have to think about like very specific use cases. You can't just generalize the risks and say, oh, you should not be using this for this, and you should not be doing this, et cetera, et cetera. The point here is you have a lot of power, but with power comes responsibility. You have to think about like, how can I potentially use my application for my particular use cases, and then appropriately think about figuring when I could use certain things, when I should not be using certain things. And that basically means that you should be thinking about not only just building these applications and trying them out, you should also think about figuring out how I can potentially build out my respective best practices for addressing the various risks associated with this particular model. So hopefully this session gave you some insights on how you could potentially address certain kinds of applications and how you can build out certain kinds of things when you are actually trying out GPT for the first time. So we are going to be coming up with a new course called Risks and Opportunities with Generative AI in Finance, wherein you'll have a lot of examples like the ones I showed you. So it will be available on QuantUniversity's website. In addition to that, I'm going to be sharing these slides and the demo, and I'm going to take some questions now. We have a couple of questions. One is, Joseph, do we have access to the Q sandbox? If not, can you share the notebook? Current students of many of our courses, including the Artificial Intelligence Risk Management program, will have access to the Q sandbox. And if you are interested in trying it out, so Joseph, I can connect one-on-one with you to see if I can give you like a trial access and show you how we can do it. But otherwise, we can also show you some code, because this was just like a simple notebook. A couple of other things which are out there. Will you be able to share the slides? Yes, we will. If you have signed up, and you will get a notification with the slides so you can watch this. Then Morgan has a comment. The paper does not share much information on the model architecture beyond the basic transform unit, nor does it tell us how many parameters there are. Their justification for lack of transparency is for public safety. So I completely agree that the amount of detail is very minuscule, and the model card is also not very robust. So it basically means they are trying to like triage requests in terms of what can be disclosed and what cannot be disclosed, and most of it is not disclosed. Even the associated risks, they claim to say, oh, we have robust practices, but we still don't know like what is the amount of testing which is being done. For example, for the number of experts, they said we have like 50 experts. Like what does 50 experts mean? What are their backgrounds? And is it 50 good enough for a model with millions and millions of parameters, if you will, right? In addition to that, we do not know where this is evolving. We don't know the roadmap, and we don't know what amounts of data is going to be stored, where will it be trained using the customer's data. All those things are open questions. So I completely agree that there is a huge element of risk associated with it, and it's not currently completely safe. What's the best way to fine-tune an LLM to your task? short answer, you should take the course because we have an example of basically building something from scratch and then fine-tuning it. So the challenge here is you are going to be building something very specific to a task for which you already have the data, which means that probably if you are comfortable with using OpenAI's API and doing all the fine-tuning on their end, then it's fine. If it's like a very benign use case, if you will, wherein you're just trying to build like a knowledge aggregation system and you can see the results and you can do enough vetting. But if you're going to be doing something very specific with customer data and you have privacy concerns, then you may have to start with like an open source model and then fine tune it on your end, which involves obviously a lot of compute. Companies are now building out services so that you can start building these private kinds of mechanisms. In your demo, does ChatGPT help create the embeddings? Yes, we actually used one of the models to create embeddings, but you don't have to use it. You can actually use some of the open source models out there to create embeddings, because embeddings, again, I can create my own embedding, right? So I could basically say, I want to create an embedding and the size of the embedding is going to be a vector of size 25. I could write my own embedding model and data it out. By the way, if you're interested in these kinds of things, there is also the search, which I did was a very crude search. For example, if I had 10,000 embeddings, now I'm doing a pairwise distance between my question and 10,000 embeddings and computing the distance and then sorting them. Obviously, no one writes bubble sort or any other algorithms today, even though you know how bubble sort works. And in the same way, you don't build a search engine in your Jupyter notebook. So you go to a specialized vector database like Pinecone or something like that, wherein you can create these embeddings and throw it onto an index. And that way, when you have a new embedding, you could basically query, are there similar embeddings? And you use both software and hardware to be able to come up with the responses much, much faster, so that your SLA for being able to get back the appropriate context and then run it against your APIs is going to be much, much faster, so that you can enhance the user experience. So you have to think about all these engineering components which kind of come into play. Okay, so there's another question. To be clear, in the demo, you're generating context to the query to OpenAI. However, the return NIST generated text are from OpenAI. So the NIST data is in the OpenAI's GPT LLM. No, the OpenAI the question is, it may already be there, but I'm providing context saying that this is where you should be looking for this particular answer. And then it's actually leveraging the context I'm providing to answer these questions. So if I had not provided the context, if it was something very benign, for example, if I'm saying, what's the birth date of George Washington? So you probably have this information in multiple pages in various websites. So you do not really require a context. So it probably just gets that information to you. But for very domain-specific problems, you may not have all the information. It will come up with an answer. But the question is, if it has to be a very focused answer associated with a particular domain or a particular context, you need to enrich your prompts with those specific contexts. So then another question, how good is LLM at reading technical documents, PL SQL code, etc.? That's a great question. I haven't tried that, Solomon. It's something you should try and let me know. I know there is a lot of work being generated with the Copilot and other stuff. I haven't used GPT for generating any code and vetting out the quality of the code which comes up. Is LLM reformatting the context that you sent to it? So I guess it kind of relates to your earlier question, Shashank. Yeah, more or less what we're trying to do is providing adequate context. So the gist here is, if I am going to be building out my own company's website and I have a knowledge base, like a technical support website on my site, and I'm going to be providing answers associated with my software product, let's say, associated with the documentation in my website, then I don't need to search the entire web. I can potentially just provide the appropriate context so that I can get the answers associated. So if I'm building a domain-specific Q&A system and a chatbot to answer those kinds of questions, this is a methodology which could potentially be used. And it need not always use the OpenAI API. So you can use any other mechanisms. Hugging Face has some demos already. you can potentially use that and build things from scratch. But the ability to be able to engineer problems so that you can leverage both large language models, an API like OpenAI, which is like one of the leading APIs, if you will, to be able to like query and get back responses. So it opens up a lot of possibilities. And I would say in the beginning, when you're still vetting out these opportunities on what's possible, try to keep the engineering as little as possible and try to leverage as many APIs as possible so that you can try things out and figure out what actually happens. And then once you're gravitating towards like building out a more of a solution, you can answer those questions on whether you should be building or you should be buying or you should be integrating and doing things from scratch, and also the associated risk which needs to be articulated. Okay. So there is another question. Can you address how to explain the answer generated from ChatGPT by providing XAI kind of explanations? How would you show a vector was a better answer? That's a great question, I haven't really, I mean, the challenge is, when you think about like explainable AI associated with other kinds of machine learning algorithms, right? So we have a lot of techniques, post-hoc explainability, you can potentially use the various techniques to answer it. But I don't know how rich the API is to provide those kinds of very specific answers to explain the rationale. But again, you can query, so how did you come up with this answer? And then get back responses. But I'm not sure if it's going to tie it down to a very specific mathematical construct to say that this is exactly the reason why I gave you this particular answer. So I think it's an evolving area of research. There are some research efforts already out there to figure out, can we explain some of these answers? But I don't think I have the answer myself, but also I don't think the API gives you a very clear idea on how to explain the rationale behind generating some of these answers. Okay, so I know we are a little over, so it's 1:06. I hope it was helpful for you to at least get an idea of what these APIs mean and what the context is in the world of finance. So hopefully I'll see you all in the course, and we'll keep the discussion going through additional webinars and lectures. If you have any questions, reach out to me, and keep an eye on upcoming webinars so that you can continue learning with us. Thanks so much again. This is Shri from QuantUniversity, and we'll be signing off. Take care. Bye-bye.